Okay, so here we have a spring problem. A mass of 4 kilograms is attached to a spring with spring constant K is 17 Newton per meter and a dash pot with damping constant C is 4 N seconds per meter. And we have initial position of 1 meter and initial velocity 7 meters per second. And we want to solve this. So from the spring equation, we know that mx double prime plus cx prime plus kx is 0. So we have 4x double prime plus 4x prime plus 17x is 0. So my characteristic equation is going to be 4r squared plus 4r plus 17 is 0. And then I can solve this using the quadratic formula. My r here is going to be negative 4 plus or minus square root of 4 squared minus 4 times 17 over 2 times 4. This works out to be negative 4 plus or minus square root of a 16 times a negative 16, because I can factor out a 16 and I'm left with a negative 16 over 8. So my r is negative 4 plus or minus 16I over 8. And I want to write this, the real part is negative a half, and the imaginary part is 2I. So now I know the general solution of my differential equation. I'm going to have x equals e to the negative 1/2 t for the real part. Then I have a cosine of 2t plus b sine of 2t for the imaginary part. So this is the general solution to the original equation. But we have some initial conditions. We know x of 0 equals 1, and the initial velocity was x prime of 0 is 7, and this is going to allow us to solve for a and b. So if I put 0 in here, x of 0, I have e to the 0 is 1, and then I have a times cosine of 0 is 1, and the sine of 0 is 0. And this equals 1. Well, this is just a equals 1, right? So I get from that condition. Well, I need the derivative in order to determine what b is. So I have to use a product rule, because I have a product of this exponential with this sum here. So my x prime here, I'm going to have negative 1/2 e to the negative 1/2 t times a cosine of 2t plus b sine of 2t plus e to the negative 1/2 t times negative 2a sine of 2t plus 2b cosine of 2t. So you see here I have the derivative of the exponential part times the trig part by itself, then the exponential part is the derivative of the trig part. Derivative of cosine is negative sine, but I have a 2t, so by the chain rule I need a 2 out here. So my x prime of 0 here, well, e to the 0 is 1, I have a negative 1/2, and then I have a times 1 plus b times 0, then plus, here I have a 1, I have a negative 2a times 0 plus 2b times 1. So what am I getting here? I'm getting, sorry about that, I'm getting what? Negative 1/2 times a here was 1, and then here I have 1 times 2 this, plus 2b equals 7. So this means 2b is 7 plus a half, or what is that, 15 halves. And so I get b here is 15 over 4. And I know a is 1 now and b here, so my final answer here, my x of t, is e to the negative 1/2 t. Then a was 1, so I have a cosine of 2t. And then b here, I had 15 over 4 sine of 2t. And that's the answer to my problem. And then in the next video, I'll show how you turn this into a trig function of a single, well, sorry, a trig function of a, what am I trying to say? A single trig function. Okay, thank you.